Hello, welcome back. Or yeah, let's see how much longer we do, but a little bit. A little bit more Onyx today. So yeah. The best one would be if we now change it that fuck my neck. That we trace probably all of the chunks at once, which might not be as straightforward with the current approach that we have. What is that? What did I do here? No idea. Let's remove that. So yeah, we would want to have one shader that basically does that. What's the best way to do that? It's not, is it? No, it might be here actually. Although there is let me think a little bit. Because currently we have each chunk has a fixed size, which we probably will keep. So each chunk will still be X amount of size. But probably what would make sense is if we do it now already a little more towards the direction we want to actually have the terrain in the end. So probably with the oak tree. Oh, my eyes. God damn it. Are my allergies coming back? I thought we are over that. So let me think again how I imagine that to be with the oak tree. I think the idea was well, actually, I think I wanted to get away from the oak tree. Wait a second. Because the thing is, we don't want to store the full terrain. But on the GPU, we still need it full. Oh yeah. I was about to eat in peace and hear oak tree. What? Do you have anything against oak trees or? Ah, okay. Yeah, well, hello. Hello. Enjoy your meal. Actually, before we do that, before we go to the oak tree, let's do one more source for CSG. That one will be a lot more complicated. New file. Yeah. So you were silent for about 7 minutes and 30 seconds. I don't think so. I don't think I was silent, but where did my new file go? Did I not create one? Okay, whatever. Rename simplex nice.h. All right. Although, is that maybe too complicated, the simplex noise on the GPU? Anybody knows that? You can grab an implementation from here. But do I want that? So what is that? God damn it, yeah, okay. WebGL noise. But what kind of noise do we have here? Simplex noise, classic noise, cellular noise, Pierce noise. I mean, I don't mind taking those if they work. So I guess this is the simplex noise, right? Yeah. Array and textureless GLSR 2D simplex noise function. Let's take it. We take the credit. I mean, I will put the credit in there. But let's take that. So let's. Yeah, it's MIT, but we will still. We will still give the. Oh, okay. I mean, it's here, taken from this. I mean, it's. Anyways, here as well, right? I guess we don't need that then. Never mind, if we have the license here anyways. No need to reinvent the wheel if someone already did the simplex noise for us. Let's just indent everything nicely to my standard, and then we're good to go. I could have taken my simplex noise from the CPU, right? But in the meantime, while you were away, I was introduced to the concept of projects.json file CMake. What? Is that where you put okay, no, I'm not sure. Projects JSON file CMake. What? Oh, you mean the CMake presets JSON? Is it that? Or is it a different one that you mean? Because the CMake presets JSON I already knew. That it exists. Or is it something different? Oh, okay, the idea is that you read. Okay, yeah. I mean, the dependencies, right? I already do with the dependencies CMake. So it's not really hard coded. So each module has its own dependencies file. But yeah, the other stuff is kind of nice. Maybe... I mean, I guess that's nice that you have like the versions here. It makes it maybe a little bit more readable than the CMake file, I guess. Well, it's definitely something that I could Is that like a... Because the link that like the project.json, it doesn't work, so I guess. But it's like there a library for it, or you have to parse it yourself? No, okay. Yeah, that's a bit unfortunate, right? So, but I mean, the CMake preset JSON is kind of nice as well. But yeah, I didn't really get it to work. I tried it only for a couple of minutes though. And that one is kind of automatic for you. But it can't do the same thing that you wanted to do. But it can, I mean, it can set as well CMake variables. So you can still do stuff like that where you configure presets and like variables and stuff like that. Yeah. Alright, so we have simplex noise here. Well, actually, let's call this. Oh, thank you for that, but no thank you. Always those offers for the cheap viewers. Simplex noise 2D. We might add the 3D version as well later, right? But for now, let's not. And then I would want to actually include CSG simplex noise 2D. And how does that work? S noise on the position, right? Yeah, and we get a height out, I would assume. So what we would do is float height is S noise on position X and Z. And then this is position X, height, position Z. Right? And then let's add here for now let's add a scale of 2, because I have no idea how that will look. Okay, why that didn't do shit. But oh wait. Oh, we need more than that, right? How does the simplex noise source work for me? Oh, that one is a little bit more complicated. Because we get out the derivative, which is kinda nice. Which I'm not sure if we can in this, but I mean, maybe. It's maybe even that, right? The gradient here. Normalize gradients, yes. I think it might actually be. So we could return vec4 here. Well. Yeah, let's try that. I don't know. Let's return that. And G? Maybe? I don't know. Let's see what comes out there. Yeah. I think a YAML makes kind of sense. I like YAML as well more. I think my whole data files I will change to YAML eventually. Let's do 2 here. And then let's put here the gradient, and this one we get away. And vec4 plane is that. Well, it's as well gradient. That one is gone for now. And then this is the position. This is the gradient and the distance. That should work, right? Although, is that just the position maybe? No, I think that is actually just the position. Because that's just the position of the voxel. I think. Well, that was obvious. That I make a mistake. Cannot convert return value to function. What? Simplex noise to the... Oh. Like 4. Okay. I mean... It's something. Not quite sure what it is, but it's something. Why would it be? What? Why would it be flipped? Or is it maybe that... Maybe we need to gradient. Yeah, gradient is gradient x z y, maybe. And then we probably would need to flip it internally, like that we don't need to do that. Oh, where? Yeah. Okay, maybe not. What the hell? Noise. Let's see. Where is the noise? Um. No, I'm still confused why that would be the case. Because I don't think the X and Y would make any difference. X and Z makes the most sense. Hmm. Yeah, something is kinda odd. But that still works, right? So that is still... Or did I break something? No. So that works. Hmm. I am more than confused. In my mind, that should work. But it clearly doesn't. Because it for some reason is flipped. Or I have no idea actually what it does. Not that that matters, but I mean, let's do that. I think that doesn't make any difference because that's just a normal. That has nothing to do with how it actually then looks. But here we get, like for the value, we get the value and that's it. And oh, I see. we combine it though. I see. That's interesting. I mean, it kind of makes sense. So maybe we do that. So we combine it basically with a... Yeah, basically we take a union, right? Or was that the union or was that get internal value? So distance of the plane minus the plane normal. Okay, no, it's not a union because a union is different, right? Yeah. Okay. So basically let's do that in the shader. So we get our plane noise gradient. Now we do that. But our noise gradient W is our plane gradient W plus our noise gradient W. Right? More or less. The normal is still scuffed though, I think. That doesn't make a lot of sense, but... Oh, okay. Well, well, well. Alright, let's try that again. Oh, that looks a little bit better. Okay, 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 we are getting there. I mean, it's very, very highly tessellated. So let's do that times 10 maybe. I think then this should be a little bit less ugly, I think. Okay, maybe not. Isn't that how I would scale it? So we get the noise, we do the frequency. Okay, we scale X and Y by a frequency, yeah. And I think the oh, then it needs to be smaller, right? Not bigger. I think I need to do 0.001 or something like that to drag it out. Yeah. I mean, now the UVs are kind of scuffed, which is very weird. Not quite sure why that happens. Why would... Fascinating. Oh, and now we... Okay, yeah, that's a lot of things that I noticed now that we need to do. So first of all, we need probably add a little bit smaller still. Bizarre. Probably I'm doing something wrong. Ah, okay. We once... Get the normal. Zero minus that. But that's exactly the same as the plane, right? Zero minus that, yeah. But yeah, for some reason... We have like low, very low noise here. And it's very bizarre. Okay, I mean, maybe that is... But why is it so weird? Like in the terms of the UVs? It doesn't make any sense. I would want to... Let's actually look at this in RenderDoc. I would want to see how that looks in RenderDoc. Because that looks bizarre. That's a lot of triangles, but okay. Ah, that looks actually pretty solid. But yeah, I think the normals are scuffed, right? Because the normals look kinda broken. Oh, wait. Actually, no, the normals look still broken, regardless of... I wonder if they look broken because of like the change in like coordinates. Maybe. I mean, what doesn't help for sure? Oh, but it's only one. No, never mind. Yeah, no, the normal is busted. Maybe we need to flip the normal. Let's see. Let's do one thing. Let's do it very, very small, the noise, right? Here, and then let's do this again. Very, very small. And let's... Well, actually, we can probably just... Let's take this one. What's the normal here? Hmm. Yeah, I mean, that's kind of... I don't know. Maybe we just recalculate the numbers altogether. Because we have to do that anyways for the other stuff. But then, yeah, there's as well this weirdness that... Oh my god, please let me fly. There's like weird artifacts. I mean, maybe that's fine. Although it's kind of weird how it looks, right? Very funky. Not gonna lie. How does the noise here work, right? We did... Ah, we gave X and Y into it. And then I split it and put that out again. Maybe we do that as well. Oh, we do it here, right? But then, yeah, probably what's wrong is what we return here. Yes, we get a Vec 3 out. Which is like... Yeah. What is M? It's a Vec 3. Yeah, it's probably that I'm doing something wrong here with... We could as well just... Let's do that. Just to see what it does. Let's take the plain normal for now. Even though that's wrong. Okay. Well, you are right. What? I am confused. I am officially very much confused. But how does that work? Again, how does that work here? The derivative. Is X and Y. And then this one gets added to the gradient. And that basically, that is X, Y, Z in the gradient. So I guess what we could do is build a vec3 x 0 noise gradient Z. But does that really do it? At least that would be what we do in the C++ implementation, but that sounds so wrong. Yeah, it looks wrong for a good reason. Because it would basically mean that we're not looking up. How does this work in what? That doesn't make sense whatsoever. Ah, wait. No. That's just that's just an armor. So that doesn't really matter. But yeah, I mean, it's kind of weird. Why do... I guess I'm not understanding my own algorithm anymore. Why would the noise gradient determine where we are in terms of height? Oh, okay, no, that looks a little bit better, okay. I mean, it doesn't look better in terms of the mesh, but... Okay, yeah, that looks reasonable-ish. I mean, it's still busted, don't get me wrong. But it looks... From a mesh point of view, it looks a little bit more logical. I think it is why it probably looks nicer in RenderDoc now. Yeah, that looks perfect. There's no weird artifacts here. Except for like this small one here, but overall that looks like way better. There's like small ones here and there. But actually that looks fine, right? It's just that it's shaded weird. But it's actually... I mean, it is... Ah, but that could be... No, it's not, because we don't have that. Yeah, whatever. I think that looks 10 times better already. I mean, yeah. What is secondary? Whatever. No difference between secondary and that, but yeah. I mean, that looks pretty good for a first try on like the simplex noise. Only question is why is the normer sometimes broken, but the normals are anyways broken for other pieces as well. So that is 2610. I mean, that looks... Oh, but here we have like... this one, right? It's a little bit weird that... this one is up here. Whereas here there is no vertex. Okay, so there is definitely something still a little fishy going on. Because that vertex kinda doesn't make a lot of sense. I'm wondering where that might come from. I mean, maybe we really want to have 0 here as a distance. So that it doesn't break. But even then it shouldn't break in that sense. Oh yeah, that is perfect not. I mean, maybe we actually do a union here. Maybe we do a union. Get union of noise gradient and plane gradient. Right? Although, yeah, no, that's not really what we want, but yeah. I mean, it will now work, but it will look kind of weird. Okay, well, that was not what I expected. What? What? Whatever. I think we want anyways how we had it. I think this is more correct, we just need to fix the noise. But that's kind of bizarre again. Not quite sure. I would need to read up that gradient stuff again for the volumetric terrain to understand that. And yeah, we probably want to go in a sense that we have like the voxel centered around 0. And I need to look at the normals. Because they are busted. Actually, can probably, yeah, I can probably debug that. We go super low again. Because then we should be basically flat, right? Yeah. And then let's see what we get as the normal. It looks like probably Z is like intensely high. Yeah. So I think we need to swap probably the Z into the Y. I mean, let's try that. I'm not sure. It's a little bit... Or what comes out if we do... I think that is garbage, right? Because we can't get a 3D noise out, like normal, out of the 2D noise. So I would say we do probably that and keep that at 0. I mean, that looks pretty good. It's still a little off, I would say. I mean, maybe we do. Let's see what comes out of that. No, that's garbage, okay. That's what I thought. I mean, maybe we need to flip that. Might be a good idea as well. Okay, no, I think That was not a good idea. But then again, I don't think it's actually correct what I'm doing here. It's not fully correct as we can see here. I am really confused how that works actually in the 2D case here, because I don't see how we would do anything different. Yeah, but what do we do with that then? Oh, we do actually 1 minus that. And then we normalize. Okay. How about we do that actually? So we do this. And we do here y and 1 minus that. And we normalize. Maybe. Oh, that actually fixed it. Man, my code was actually correct in C++. Who would have thought? Perfect. Where is my spotlight? Oh, it works. Oh, I did a sphere there. Oh, beautiful. And the numbers actually work for that. They look actually pretty good. I love it how I make random spheres. Beautiful. We got simplex noise. So what we can do now is 10. Oh, yeah, that makes sense. So that's something we need to address as well. Yeah, because that doesn't work, which makes kind of sense. So I need to address that. Give me a second. So for that we need in the init generate mesh path. So we need create so that's 8 vec3 f chunk file transform, and then we have the cell size, and then that's basically that. And before cell size we give the chunk position. And for that we need to go to terrain panel. Chunk position is this. We should make that nicer in general, but it will work for now. Size and volume chunk chord. Then this is the junk position. We feed that in. And then here we do a vec3 transform. That should already do it, if I didn't make a mistake, which I probably have. But that should make it now that we have like a terrain. Yeah, of course I did a mistake. That we have a terrain failed great transform undeclared. Oh yeah, of course. Always the same. Okay, so and now if we do 10 by 10 by 10, we should have like a nice, well, or not. Okay. Okay. I mean, it's almost. It almost works. Or? I'm not quite sure actually. Okay, now something is wrong, right? I would say something is wrong with the positions. Oh, wait. I think I know what it is. Hold on. So we do that. But we have a vec4, a vec3 sample position. And that one is this plus the position. Because the position of the voxel should still stay within the local space. I don't think that will necessarily fix the... Well, it should actually help. Okay, well, that didn't work. Why would you... What the hell? Why? Why would you be like that? Wait, what? Oh, wait, I know why. Damn it. 0. Because the generate mesh took it. And that's something we don't need as well. Yeah. And let's do 64 here. And that is more or less matching now. Yeah, we just need to have... Although it's not really matching. Nicely. It's a little bit weird. I would have assumed that this should be better in terms of... Because it doesn't look like that matches nicely. That's something we have to think about. That doesn't look too good. I'm not sure why that would have worked in... I mean, maybe it's the density of our voxel. Although that should be kind of dense already. Yeah, I'm not sure. That's something to consider as well. Because even with skirts, if I generate skirts, that doesn't help. Because the gap is quite huge, so probably there's something else going on. Although it does seem to match quite well. So maybe with skirts it would already work. Maybe it actually matches. Not so bad. Although this is kind of weird, right? It feels like there's a lot of difference. Yeah, it feels like it generates quite a lot of difference here. Like, this is definitely not what it should be. So I doubt this helps, right? Because, I mean, in the C++ we do that. In the C++ version we do that. We flip the derivative completely. But I don't think that has anything to do with that. I mean, it could. Maybe. But I don't think so. Yeah, I don't think so. Yeah, doesn't really help. Still. It's still quite a difference. Which is a bit weird. Because shouldn't that be the exact same point? I would want to know that now. So let's actually render doc. That's what I wanted. Let's add 2. Oh, and here we already have it. And let's take a sample here. Well, actually, we don't even need to go close as this. Although maybe it's not overlapping, right? But even then, it shouldn't be this drastic of a difference. But let's see. Where is my pipeline state here? Well, actually, I wanted to have the mesh viewer. So that is 0, 10, 0. It's 9.95 and 10. That is the same position, right? Maybe not. I guess I have to think about that a little bit, why that might be a problem. But I think that the oh, but shouldn't that be the same thing? I mean, maybe it's floating point precision issue. But I mean, the cell size here is like huge. So it's maybe not the problem with the floating point. I would have to think about it, but I think I will call it a day for today. We did anyways quite long already. And we will be back tomorrow, but we got the noise running, which is nice as well. But yeah, we would need to definitely look at this. Which, I mean, here in like the exit actually aligns quite nicely. So maybe it's enough if we just do the skirts. I don't know. We would. I don't know. I want to investigate a little bit more. If it's just that that's missing. But I mean, that is pretty good here. But instead, it somehow feels off. I mean, maybe not actually. Maybe actually it's not so bad. If I'm like far away, right, I can barely see it. And then close up. Maybe with the skirts it's fine. I could try generate them and see if that helps. So how do we do them? Wait, let me think again. Because I think we already did them with the volume load request here. Probably. Oh, where is it? Or did we not do that? Maybe we didn't do it. Maybe I need to, yeah, I need to go here. And instead of clamping, I should treat it as air. Is right boundary. Is that how you write boundary? No, right? I think it's just boundary like that. Probably, maybe. Boundary. Alright. And that is basically if our voxel coordinate plus 1 is the grid size in X. Is left boundary. If voxel coordinate is 0. Although we don't really do treat that, right? Because we don't go into that direction, so we don't need that, I think. Pool is top boundary. Is front boundary. And then we basically get rid of that. And then if I mean, I guess we could do that. But then yeah, we need to basically, so this, the voxel index 2, if is top boundary, then we do a vec, or then we construct a voxel here. Otherwise we do this. What do we need that voxel for? Actually just the gradient? Okay, well then, whatever. So here is top boundary. Otherwise we do a vec 4, 0, 0, 0. Oh, like we could do the gradient. But air, and air is 1, right? And then the vec 3 is as well, while it is a top boundary or front boundary. Vec 4 is right boundary. I think that is correct, but I'm not sure. And then this is right front, okay. Right or front boundary. And then 6 is right top. That one is basically all three, right? Right, top or front. Seven, 7. And corner 1 is front. Let's see. I'm not sure if that was correct how I did. I think it could work with the skirts like that, but I'm not 100% sure. Okay. X, Y, Z. Ah, well. Yes, yes, yes. Yeah, that was expected. I expected that. But let's do 32. Yeah, because now we have like this, right, where we are in a cube, basically. But let's not deal with that for now. Oh. God damn it. Okay, it's not that simple then, I guess. Alright, never mind. That's not correct. I would need to look at the... How do we do that again? In like the dual grid we do that. Skirt. Okay. Something like that. But I would need to look at that again, how that works. If we are... Oh, but... Yeah, okay. I need to look at that, but we do that tomorrow. So let's revert that. But yeah, thank you very much for joining. We will be back tomorrow. And then we will... Yeah, we will look at the generation actually. Well, not the generation, the thing that is the stream title now, which is hitting the terrain only with one ray once and then doing the correct update instead of updating all of them, all of the chunks, because that is not very performant and currently a bottleneck if we would want to edit big words, because we don't want to regenerate the whole loaded word. Yeah, but thank you very much for joining as usual. We will see each other tomorrow, as I said. Same time, same place. So yeah, we will start at 2:30 as usual. Have a nice rest of your Saturday. And yeah, hope to catch you tomorrow. Good night. Bye bye.